All right, so looking at number 23 here on 3.6, we're given this composition f of g, and we want to take the derivative of that at the point 4, and they give us the two individual functions f and g here. So this goes back to some pre-calculus stuff, but f of g says to take the function g and plug it into f. You can also think of it like this, f of g of x. Okay, so what we're going to do is we're going to take g of x and the entire thing of g of x, 6 root x, and plug that in as the variable of f. So if f is this cosine pi u over 24, then it's still going to be cosine, we're still going to have the pi, but now my u I'm going to replace with 6 square root 6. And we can simplify this down a little bit. So 6 over 24 simplifies down to be 1/4. So we get pi square root x over 4. Okay, now we want to take this and we're asked to find the derivative of it. So it's going to be a chain rule, which is why they broke it down into f and u like this. And I know the book has one way of doing chain rule stuff, but I usually think about it like this. To do a chain rule, you're going to do the outside function first. The outside function is cosine of the inside function. Derivative of cosine is negative sine. You leave the inside alone, and then you want to multiply this by the derivative of the inside. Pi over 4 is the constant, so that's going to stick around. Square root x, you want to think of as x to the 1/2. So you're going to multiply down that 1/2, leave the x alone, subtract 1 away from the 1/2. 1/2 minus 1 is negative 1/2. And then you just clean this up. So we have a bunch of constants, the pi over 4 and the 1/2, that you can just multiply together and bring out front. Pi over 4 and 1/2 is pi over 8, and we still have the negative sign. This x to the negative 1/2 you can move to the bottom. So we could do sine of, pi square root x over 4. And then in the bottom now we have x to the 1/2, which is just square root x. Now they didn't want this derivative just anywhere, they wanted it at 4, so now we can plug in x to be 4 into this and see what we get. So it's going to be negative pi over 8, sine of, we have the pi, square root 4 is 2 all over 4, and in the bottom we have the square root of 4, which is 2 again. Sine, this is pi over 2, and sine of pi over 2 is just 1. So we get the negative pi over 8 times 1 over 2, which is negative pi over 16. And that should be the answer for this one. So just to type it in, just to see. Negative pi over 16. Okay, cool. All right, so looking at the next one, pretty similar stuff. I'll just scroll down here on my thing. So again, it's f of g, that composition derivative, and we have our f and we have our g. So first things first is let's actually find f of g of x. This says to take the entire function g, 2x squared plus 5x plus 1, and substitute that into the variable of f. F is the 6u over u squared plus 3. So we're going to do 6 times the new variable, 2x squared plus 5x plus 1, all divided by the new variable, 2x squared plus 5x plus 1, all squared, that plus 3. So all this is replacing the u with the entire function g. We can try cleaning this up a little bit. It's gross. But maybe multiply the 6 into the top, and then you could even square this thing out on the bottom. So squaring this out, I don't know how you were taught how to do this, but you could do the box thing where you have 3 rows and columns. So 2x squared, 5x and 1, and then here 2x squared, 5x and 1. Multiply all this stuff in the inside and then add them all together. And then don't forget the plus 3 on the end as well. However you want to do it. I would probably do it this way. So we would distribute the 6 into the numerator. Square this thing all together, so kind of doing the box thing all in one go. We're going to multiply the 2x squared times all 3 terms, the 5x times all 3 terms, and the 1 times all 3 terms. 2x squared times 2x squared is 4x to the 4th. 2x squared and 5x is 10x cubed. 2x squared and 1 is 2x squared. And now 5x times all this stuff. 5x times 2x squared is 10x cubed. 5x times 5x is 25x squared. 5x times 1 is 5x, and then the 1 times all that stuff. So just 2x squared plus the 5x plus the 1, and then don't forget the plus 3. Just copying the numerator down. Combining all like terms, we have a 4x to the 4th, which is just by itself. I have a 10x cubed and another 10x cubed, so 20x cubed. Squared, I have a 2x squared, a 25x squared, and a 2x squared, so that's 29x squared. I have x's, just a 5x and a 5x, so 10x. And then I have a plus 1 and a plus 3, so plus 4. Okay, this is the composition, but now we want to take the derivative of this, which is going to be pretty ugly looking, and it'll be a chain rule. So that's bottom, I'm not going to bother writing this down, but this entire bottom function times the derivative of the top, which is 24x plus 30, minus the top, I'm not going to write that down, times the derivative of the bottom, which is 16x cubed plus 60x squared plus 58x, I'm out of room here, plus 10. That all divided by that bottom squared. All right, so this would be awful looking if you wrote it all down, but what's really nice is that we're plugging in x to be 0. So pretty much everything's going to go away. If I plug 0 into the original denominator, I get 0, 0, 0, 0, 4. So I have a 4 there. If I plug 0 into this parentheses here, I'm just going to get that 38. Minus, if I plug 0 into the numerator here, I get 0, 0, and 6. Times, if I plug 0 into the derivative I did over here, I'm just going to get that value 10. And that's all divided by the denominator, this. But remember, plugging 0 in, I just got 4 squared. And so you can just type this into the calculator and get an answer. So I know that this derivative is like really awful, but what's nice about it is that you're just plugging in x to be 0, so almost everything simplifies out. Don't stress out about writing out the derivatives out, especially when they're these awful polynomials, if you're just plugging in something nice like 0. Just figure out what goes where and then plug the numbers in. All right, 25 was asked as well. Find the tangent to this at x equals 4. Okay, let's look at this one. So just to copy our function down, y is x minus 2 over x minus 3, and it looks like that entire thing is squared. Okay, so if I want to find the tangent line, first I have to find the derivative of this. And you could do a chain rule here, because we have this fraction raised to the second power. So derivative of the outside is the fact that it's to the second power, so we just bring the 2 down, leave the inside alone, take 1 away, so now it's to the 1 power. But then we have to multiply that by the derivative of the inside, which unfortunately is a quotient rule. So bottom, x minus 3, times the derivative of the top, which is just 1, minus the top, x minus 2, times derivative of the bottom, which is 1, all over the bottom square. All right, so again, just to explain chain rule, derivative of the outside is the fact that this whole thing is squared. Bring the 2 down, leave the inside alone. Times the derivative of the inside, which is a quotient rule. Okay. Now, again, right, you could clean this up to find the actual derivative, but if we're trying to find the tangent line at 4, let's just go ahead and plug 4 into all of this and simplify down the numbers instead of simplifying down the polynomials. So we get 2, x minus 2 is now 4 minus 2, so 2 over 4 minus 3, 1, times 4 minus 3, 1, times 1, minus 4 minus 2, 2, times 1, all over 4 minus 3, 1 squared. 2 times 2 is 4. This is 1 minus 2, which is negative 1 over 1. And then 4 times negative 1 is just negative 4. That's going to be my slope. Remember, the tangent line has the same slope as the original function. So we take the derivative and plug in the point to get the slope. Now that we have the slope, we also need a point. We get the point by plugging 4 into the original function to get the y value. If I plug 4 into the original function over here, I get 2 up top minus 1 squared, so also 4. And now that I have my slope and my point, it's just going to be y minus the y value of the point is equal to the slope times x minus the x value of the point. And then you can clean that up. Or you can just probably type it in like that and it'll count it right.